So I'm going to explain. Okay, so one of the artificial intelligence informed search algorithm, which is simplified memory bounded A star algorithm. Okay, so last class we discussed about A star algorithm and how to calculate the value for A star algorithm. Okay, so the same thing. I hope that you can view my paint. Okay, so paint picture. So A star algorithm. Okay, uh, the functional value. Okay, the functional value which will decide. Okay, it should be the functional value should be minimum, which will decide the movement of node through a particular particular node to node penetration will be function of addition of heuristic function, okay, plus cost function. Okay, cost function we have seen in the map itself. Okay, the initial map, whatever we see, no, the map. Okay, so in that they have given the cost function between two nodes, and similarly the heuristic function we have seen in the tabulation. Okay, heuristic function is a straight line function. Okay, so the straight line distance between the things. Okay, so let me show that heuristic function. This is heuristic function. Okay, so the distance between each node to the destination is Bucharest. That's why it is mentioned as 0. Okay, so similarly the cost function is in the map itself. Okay, you can see the cost function. Okay, so this is cost function. It's given in the map. Okay, from each node to node they have given us a cost function. These two things we are adding and we are coming with the function for our A star algorithm, but this is memory bounded A star algorithm. So same, the value whatever we are taking here is same as a function of this only previous A star algorithm, but here you can see there is a one extra block is there on the head of each node. Okay, you can see this is infinity. Okay, for initial node, while searching an initial node, it is assumed as a infinity. Okay, so this name itself memory bounded. Okay, so that this block defines the memory bounded to search in an algorithm. Okay, so initially the memory you cannot give any value, so we are starting with an value of, okay, infinity. Okay, so later we are slowly moving to node. Here you can see they have given, this is a functional value of each node. Okay, 393, 447, 449. Okay, in that we will see, okay, we will see which is the minimum value. So Cebu is having a minimum value. Okay, Cebu is having a minimum value. We have to allot a memory function for Cebu. How we will allot means simple rule. In the same parallel branches which is having a minimum, okay, which is having a minimum value, okay, functional value, that will be taken as a, okay, your memory value of the particular node. For example, Cebu is 393 when compared to Timisoara and Zerinth. Okay, Timisoara, Cebu, when compared to Cebu, Timisoara is having a minimum value. Okay, so 393, okay, 447, 449. Okay, so in this 447 is minimum when compared to, if you compare this value with these two, okay, this 447 is minimum. So that value we are fixing as a memory value for Cebu. Then we are seeing which is the minimum value of Cebu. Okay, child node which is having a minimum value. Arad is 646, Faragas is 415, and Oradio is 671, and Rimnisu Vilcia is having 413. Okay, so definitely 413 only we will select to penetrate. Okay, but for 413 we have to allot a memory for that. Okay, memory bound for that. We will see the parallelly Farragus is having a next minimum value 415. Okay, I am allotting 415 as the memory for the Rimnesu Vilcia. Okay, then I am checking with their child node. Okay, if I check with the child node, it is 526, it is 417 and 553. These all the three values are maximum more than my allotted memory value. So I am stopping here. So I have to see which is the next minimum value. Okay, next previously the minimum value is 413. The next minimum value is Farragus. So after unwinding back to Cebu, and we need to expand the Farragus. Okay, so before expanding through Farragus, this is minimum value. No, I need to change it. Okay, so how I will change means I will see the parent which is next minimum value 417. Okay, so I will change this 413 value as 417. That only done here. 413 is changed to 417. Next I am expanding to Farragus. Farragus, I have to allot the memory value. Farragus next value is 450. Next minimum value is recently allotted 417. Okay, that I am fixing here 417 memory value. Then I am expanding Farragus, Cebu and Bucharest. Bucharest is our destination. Even though our destination, this value is more. 450 is more than 417. So this is a wrong path. It will say the path is wrong. So next move to the minimum value. Okay, then Farragus minimum value is again okay Rimnesu Vilcia, which is 417. So next step is step C is switching back to Rimnesu Vilcia and expand it through its child node. Okay, so we are coming back to Rimnesu Vilcia. Okay, and for Rimnesu Vilcia we are fixing a okay, and a very important thing, Farragus value we need to change. Then only Rimnesu Vilcia will become minimum. So to make it minimum value, Farragus value will get changed from 415 to okay 415 to its child minimum value we will take. Okay, its child minimum value is 450. Okay, Bucharest. So we will change that to 450. We are changed to 4. So this will become minimum. So 447. We will expand that to child node. Okay, child node we are having a Pitistia, Cebu, and Creo. Okay, in that 526, 417, and 553. So definitely 470 is minimum. We will expand through this. Okay, but for this we need to again allot the memory. Okay, we will see the neighbor 526 and 553. 526 is minimum, but also we will compare this 526 with the parent memory allotted. Okay, parent memory allotted is even minimum than this, so we cannot take this as a memory. We have to continue the same memory value here also. Okay, so 447 we are allotting. Okay, then we are checking with their children node as Bucharest is 418, Creo is 615, and Rimnesu Vilcia is 607. Okay, so Bucharest is our goal node. So this is minimum now, even when compared to the memory allotted as 447. Okay, 418 is minimum. Then we will say this is the desired result. Okay, this is our result. How we attained means first Arad, then Cebu, then Rimnesu Vilcia, then Pitisti. Okay, then we reached our destination Bucharest. So if you use the memory bounded algorithm, the path will be like this only. Okay, So very simple only. Even I will anyhow. That's why I recorded this video also. I will post that. Okay, if you have any doubt, you can recall that. Okay. So you are having a 3-mark question. Okay. So the 3-mark question. Maybe I'll give a this diagram only, and I will ask you to what is how we will proceed using this algorithm. Okay, what is the desired path? Okay, you need to only tell this. Okay, you, you have to tell this path. We have to move this if we use memory bounded A** algorithm. Okay, so like this, there is a chance of asking question for a. So we know that okay, 13 MCQ and 12 marks means 3 into 4. Okay, 12 marks. So this bigger questions will have these combinations of questions only. Okay. So this is one thing, and I will anyhow time is less, so I'll take another 5 minutes. Okay, to explain hill climbing algorithm and genetical algorithm. Genetical algorithm, most of you know. Okay, yeah, brief introduction is enough. I'll tell about hill climbing algorithm. So what is hill climbing algorithm means? If you are generally hill climbing algorithm will be used wherever you are having a graph like this. Okay, it can be anything. Okay, voltage versus current or something. Okay, so you need to find the maximum value. Okay, this maximum value will be your power value, right? P max. Okay, so even if suppose you are having a graph like this. If you see here, if I take voltage, voltage will be maximum here. If I take current, current will be maximum here. But when the power will be maximum means here. Means this will say that I peak. Okay. Similarly, this will also tell voltage peak. Okay. So the multiplication of this will tell P max value. Okay. Power maximum value. So the objective of this, if they give an unknown, okay, so you are having one plot, okay, it's a plot, okay, you want to find the what is the maximum value, okay, P max value with the given time. It can be a fraction of second, okay. So your algorithm need to find the peak value. So what hill climbing algorithm will do, it randomly take one value. Okay, so it randomly take one point here. Okay, and at that point it will fix the value as x. Okay, x is your initial point. Okay, and it will start moving randomly. Okay, means either left or right. Okay, it will move to the next point. Okay, this next point, okay, will be x dash. So what is x dash? X dash is equal to x plus del x. So this change, small change in x value, okay, will give your x dash value, and it will compare your x and x dash. And if your x dash, if x dash is better, okay, it found that if your x dash value is better, then it will start moving to x dash to x double dash. Okay. What is x double dash means? It is x dash plus del x. Okay, so like that it will start moving from point to point, and it will find the by comparing, okay, comparing, it will find the better value. Okay, so I am assuming that it can randomly take any value and it is moving like this towards my right side, and it is comparing this value. Take example 10. Okay, next value will be 8. Okay, so again it will stop here and it will tell that this is a maximum value. Okay, we'll say that it's a local maximum, or we'll say that goal maximum. Your algorithm will tell that this is the maximum value in the given data. Okay, but it's having a advantage. Based on advantage, we are having the different types. Okay, so one of the advantages, say for example, you are having a peak like this, because if it's a single curve means easily normal hill climbing algorithm you can find. Okay, so here also we will assume voltage and current. Here also your searching point is starting here. Okay, so it is moving like this, and it is finding this is maximum. Okay, but once it arrives, this is the maximum. It will tell that the program got ended and we found the maximum value using algorithm. But whether it is right, no. Okay, so what they are naming this as this is a local maximum. Okay, this is local maximum. The algorithm failed to search, especially in this curve. Suppose if it starts searching, it will tell, but actually which is real maximum, we will say this is a global maximum. So here the algorithm failed to find the global maximum, and it is assuming itself that it have achieved the maximum value. That is one disadvantage. The next disadvantage is, suppose you are having a curve like this. Okay, even we'll take curve like this. Okay, so we are having a curve like this. Okay, so what will happen? The algorithm will start searching like this. Okay, while searching here, it will get one value, say for example x dash. It will again compare this value, say for example x double dash. It will compare these two value, then it will find x dash is equal to x double dash. Again from x dash, it will compare the value x double dash, it will compare the value with x triple dash. Say for example this point. Again it will tell that both the values are same, then it will assume that this is the peak maximum. Okay, this is also wrong. Okay, this is one another problem. And suppose you are having a graph like this. You are having a graph like this. If suppose I am fixing a point like this, it will tell it is maximum. Even I will tell that probably it have to change. Then again it will go here and it will tell maximum. But maximum is here. This is another disadvantage. Accordingly, so we will tell this is a ridge. Okay, this is ridge type. Okay, this will tell that as a plateau or flat. Okay, so these are the different occurrence of the event. Okay, so for this we are having a different way to approach this. Okay, one of the way is iterative hill climbing algorithm. What the name itself, iterative. Okay, so what will happen if you are having a curve like this? If you are having a curve like this, it will find here, it will stop the iteration and it will compare with the global maximum value. If the value is not attained, again it will start iterating it. Okay. So next is next method is stochastic. Okay, stochastic hill climbing algorithm. So that is especially for this flat curves. Okay, whenever you are getting a flat curve, there will be a certain probability will be allowed. Okay, we will say that probability as Gaussian distribution. Okay, Gaussian distribution. So even your x dash is okay, not best. Okay, even the x dash is not best, it will proceed for some probability. Okay, it will again will check with x triple dash. Even x triple dash is not best, again it will check okay, in some point it will find that this is the maximum. Okay, we will give a probability of checking that, means we will tell that probability is 10. Okay, after 10 point even you are getting the worst value, then what is your last best you have to take. Okay, suppose here 7 only is there. Okay, so 8th point you will get the maximum, so it will tell okay, we have find the maximum value. So these are the three different types of hill climbing algorithm. Genetical algorithm only just definition is required. Okay, genetical algorithm is nothing but you like your DNA. Genetics means what? DNA. It will have a hidden previous memory and it will try to search for the next level. Okay, I'll stop here. I have already taken 5 minutes. Thanks. Okay, so let me take on attendance.